Alright guys, in today's video we'll be discussing factorization method as a method of evaluating limit of a function. Factorization is simply the technique of writing a particular expression as a product of simpler terms or factors. And in order to factorize the given expression, different approaches can be taken. In my last video, I split this factorization method into different approaches, where I mentioned one, the normal factorization method, the difference of two squares method, factor theorem, and so many other methods. Now in this video, I'll be talking about the normal factorization method. Alright, the name normal factorization is not really a conventional name. I use this name simply because it is a very common method of factorization. Alright, we will take some practical examples to better explain how to use this method to evaluate limit of a function. So let's take some examples here. Evaluate the limit of the following functions. I limit as x tends to 2, 3x squared minus 7x plus 2 all over x squared plus 2x minus 8. Limit x tends to 2, x minus 2 all squared upon x cubed minus 4x squared plus 4x. Let's also take this one. Limit as x tends to 2, x squared minus 5x plus 6 all over x minus 2. Let's also add this one. Limit x tends to 1, x squared plus x minus 2 all over x minus 1. Alright, let's try to tackle these problems. We have solution. Let's take the first one. Limit as x tends to 2. We have 3x squared minus 7x plus 2 all over x squared plus 2x minus 8. Alright, now to evaluate this function, this limit of a function, the first method that should come to your mind is direct substitution method. That's the first method that you should use to solve the limit of a function. Now, by direct substitution, let's see what we'll get. If we directly substitute the values of x to be 2, we have 3 into 2 squared minus 7 bracket 2 plus 2 all over 2 squared plus 2 into 2 minus 8. And this gives us 2 squared is 4, 4 times 3 is 12, minus 7 times 2 is 14, plus 2, all over 2 squared is 4, plus 2 times 2 is 4, minus 8. And this gives us 12 plus 2 is 14. We have 14 minus 14 all over 8. 4 plus 4 is 8. We have 8 minus 8. So we have 0 upon 0. And this is indeterminate expression. Whenever you have 0 upon 0, it is indeterminate, infinity. And when we encounter this kind of problem by direct substitution, we now have to look for another method to evaluate this limit. And the best method, the next method that should come to our mind, considering the nature of the function, we can now look at factorization method. And can also consider the nature of the function, we can also use the normal factorization method. At some point, there are some questions that we need to use the difference of two square method to factorize. But for this one, we can use the normal factorization method. And let's look at how we use the normal factorization method for this question. So I can say where the limit of the function is indeterminate, comma, by factorization method, we have, now let's now use factorization method to evaluate this. Limit x tends to 2, you have 3x squared minus 7x plus 2 all over x squared plus 2x minus 8. What we simply need to do here is to factorize this expression, the numerator and the denominator. Factorize them and see the ones that can clear out, especially from the part of the denominator, because our problem is coming from the denominator having 0, and that's why our solution is indeterminate. So if we can factor this expression into lower factors, into simpler expressions, so that we can clear something from this denominator, then we are good to go. So let's try to look at the way of factorization. So we have this question, 3x squared minus 7x plus 2 upon x squared plus 2x minus 8. Let's try to work with the numerator. Let's try to factorize the numerator. We have 3x squared minus 7x plus 2. How do we factorize this expression using our normal factorization method? Now, we simply multiply this constant term 2 by this coefficient of x squared. So we have 2 times 3. When we take that 2 times 3, which is 6, they will now find the LCM of 6, the factors of 6. So when we take lowest common factor, we have 2. 2 go here, we have 3. 3, we have 1, and then 1, we have 1. We've listed all the factors here. So we have 2 times 3 times 1. Now the problem here now is, how do we combine these factors into 2 terms such that when we add them we get minus 7, and when we multiply them we get 6, because we did 3 times 2, we get 6. All right, when you add you get minus 7, when you multiply you get 6. 3 times 2 6, because the coefficient of x squared is 3. All right, now, and there are 2 possible ways we can combine this. Either we combine that 2 times 3, or we combine as 6 times 1. These are the 2 possible ways we can combine in 2 terms, because we are looking at 2 numbers that we can combine. There is nothing we can do with 2 and 3 to give us minus 7. Totally out of it. Nothing we can do with 2 and 3. But we can use 6 and 1. We can do something with 6 and 1 to get minus 7. Now what do we do with 6 and 1 to get minus 7? We say minus 6 and minus 1. So that minus 6 minus 1 is minus 7. And minus 6 times minus 1 is 6. So we've gotten the 2 numbers, minus 6 and minus 1. So we'll go into this expression, say 3x squared minus 6x minus 1x, which is minus x. This gives us minus 7x, then plus 2. Then we can now factorize common terms here. What is common here? We have 3x. When we factor out 3x, we have x minus, factor out 3x from here, we have 2. Common term between this one, we have minus 1. Factor out minus 1 from here, we have x. Factor out minus 1 from here, we have minus 2. See, the terms inside the bracket are the same. We pick them out, one of the terms inside the bracket, and then we pick this one and this one, 3x minus 1. And we factorize this expression. This is the factorization of this expression. And that's the normal way of factorization. Now let's try the denominator. Denominator is x squared plus 2x minus 8. Now, for this, the coefficient of x squared is 1. So there is no need to say this times this. Well, you can still say 1. The coefficient here is 1 times minus 8, which is minus 8. So, but we are making use of 8. We take this 8. We find the factors of 8. We say 2 go, we have 4. 2 go, we have 2. 2 go, we have 1. And then conclude with 1. We have 1. So we have 2 times 2 times 2 times 1. Now the problem is, how do we manipulate these terms, these values, these factors in 2's? How do we manipulate? How do we combine them in 2 so that when we add them, we get 2, and we multiply, we get 8? There are different possible ways of doing this. We can combine this thing as 2 times, then this one is 4. We can say 2 times 4. We can also say 8 times 1. I believe these are the possible combinations possible ways we can combine these terms in 2's. Right, 2 and 4 or 8 and 1. Now we look at these two combinations. Which one can satisfy this? Definitely this is out, because 8 and 1 cannot give us 2 either by addition or subtraction. So this is out. So work on 2 and 4. How do we combine 2 and 4 to get 2? The best way is minus 2 plus 4, or 4 minus 2. So 4 minus 2 gives us 2, and 4 times minus 2 gives us minus 8. So the terms are 4 and minus 2. 4 minus 2, 2. 4 times minus 2, minus 8. And, okay, if we put this here, we have x squared plus 4x for this one, then minus 2x for this one, then minus 8. What is common here? We have x into x plus 4. If you factor out x from here, you have x. Factor out x from here, you have 4. What is common here is minus 2. Factor out minus 2 from here, you have x. Factor minus 2 from here, you have plus 4. Note that the term here and this should be the same. So we pick one of them and then pick the one outside. And that's the factorization. Now let me give you guys a simple trick on how to factorize this. Whenever you notice that the coefficient of this expression, coefficient of x squared in this expression is 1, whenever you notice that the coefficient of this expression, the coefficient of x squared is 1, there's no point going through this process if you've gotten these two numbers. I'm not talking about this one where the coefficient is 3. I'm talking about when the coefficient is 1. Whenever you've gotten these two numbers, when the coefficient of x squared is 1, what you simply do is x, put the value here, plus 4, this is a positive 4, and then x, this is a negative 2. And that's the factorization. No need to go through this point. When you've gotten the two numbers that satisfy this expression, say x, put the first term, and then bracket x, the next term, and that's the factorization. So we've been able to factorize these two expressions, and then we can write it in this our problem. So we have limit as x tends to 2. For this numerator, we got x minus 2, 3x minus 1, and the denominator we got x minus 2, x plus 4. At this point, you can see that this can clear out this, and so this gives us limit as x tends to 2, 3x minus 1 upon x plus 4. At this point, you can now substitute the values of x. So this gives us 3 into 2 minus 1 upon 2 plus 4. This gives us 6 minus 1 upon 2 plus 4 is 6. This is 5 upon 6. And that's the limit of this function, 5 upon 6. Okay, for the next example, we have limit x tends to 2 x minus 2 all squared upon x raised to the power 3 minus 4x squared plus 4x. Okay, now let's look at how to solve this too. By direct substitution, which I told you guys is the first way of evaluating limit of a function. If you substitute the values of x directly into this, you have 2 minus 2 all squared, and then you have 2 raised to the power 3 minus 4, 2 raised to the power 2 plus 4 into 2. And this gives us 2 minus 2 is 0 squared upon 2 raised to the power 3 is 8 minus 2 raised to the power 2 is 4 times 2, 16 plus 4 times 2, 8. 0 squared is 0 upon 8 plus 8 is 16. 16 minus 16 is 0. Indeterminate expression. You see, by direct substitution, we can't get the value of this limit. So we now use another method to evaluate this limit, and we'll be using the factorization method. And let's see how it works. Using factorization method. Let's see, limit x tends to 2 x minus 2 all squared upon x raised to the power 3 minus 4x squared plus 4x. Okay, this is limit x tends to 2. For the numerator, we have x minus 2, x minus 2, because this is x minus 2 all squared. And for the denominator, factorization method, the normal factorization method, is about factoring out common terms. What is common between all of these values? We have x is common. We factor out x from this, we have x squared. Factor out x from this, we have minus 4x. Factor out x from this, we have plus 4. All right, now this is a quadratic expression. We can now also factorize this quadratic expression. Remember, the definition of factorization, reducing a particular expression into simpler terms or factors. So we need to reduce this one to linear factors. So let's talk about how to factorize that. So we want to factorize x squared minus 4x plus 4 using the normal approach, normal factorization method approach. So like we said earlier, the coefficient here is 1. We simply find the LCM of 4 here. We'll simply find the factors here. We have 2 go here, we have 2 go, we have 1, then 1 go, we have 1. So the factors are 2 times 2 times 1. Now the next thing is to look at two possible ways of combining these terms in 2's. Combine these values in 2, so that when you add them you have minus 4, and when you multiply you have 4. And the possible ways we can combine this is 2 times 2 or 4 times 1. There is no way we manipulate 4 and 1 to get minus 4, either by addition or subtraction. If you do 4 plus 1, it cannot give you minus 4. 4, it cannot give you minus 4. This is out. So we can now work with 2 and 2. What can we do with 2 and 2? With 2 times 2 to get minus 4. The best we can do is minus 2 times minus 2. Sorry, minus 2 plus minus 2. We can add them, minus 2 and the next minus 2. When we add them, get minus 4. And we multiply them, we also get 4. And like I told you guys earlier, when the coefficient of x squared is 1, what you just need to do is say x minus the first term here 2, x, then the next term, because we are dealing with minus 2 and minus 2. These are the factors. So x the first term minus 2, x the next term minus 2. That's the factorization of this. So we will come back to this. We now factorize this. We have limit x tends to 2, x minus 2 for the numerator, x minus 2, upon, we have x here. For this one, we factorize it as x minus 2, x minus 2. So we can now clearly see that this will kill this, and this will kill this, and we will be left with limit x tends to 2, 1 upon x. At this point, we can now substitute the values of x, and this gives us 1 upon 2. And that's the value of this limit. With these two examples, I believe you can now try out example 3 and example 4. See you guys in the next video on methods of evaluating limit of a function.